Okay, so we're going to run through an example of using a hypothesis test for an unknown population mean. And that involves using t-distributions again. So what we're making use of is the fact that sample means, our x bars, have a t-distribution with degrees of freedom equal to the sample size minus 1, so n minus 1 degrees of freedom. And we have to use the t-distribution when we don't know the population standard deviation sigma. So if we don't know sigma, we have to approximate it with the sample standard deviation s. And when we do that approximation, we introduce more variability, which means we need a distribution that has slightly fatter tails than the normal distribution, and that's where the t-distribution comes in. So our hypothesis test on a population mean, where we're using x bar to do our test, is going to require the distribution for x bar, which in this case will be a t-distribution. So the example is based on nicotine content in some cigarettes, and we are testing the claim from the manufacturer that there is no more than 40 milligrams of nicotine in their cigarettes on average. Now, what you're actually given is some raw data. You're given 10 data points, and we're told that they are at least roughly normally distributed. So the relevant statistics are going to be the sample standard deviation, which is given to you as 3.8, but you could actually calculate that yourself if you wanted to. The sample mean is actually not given, but if you add up those 10 points and divide by 10, you get 43.3, so that's what the x bar ought to be. Sample size is 10 because we have 10 data points. Our significance level is pretty strict, 0.025, so that means our test statistic can occur no more than 2.5% of the time simply by chance. So we'll see how to use that at the end of the example. All right, the stated population mean for the nicotine content of all cigarettes is 40 milligrams. And we believe that it's actually higher. So we're going to set up a statistical test, and we're going to use the x bar we got from our sample to see if we have strong evidence that, in fact, the mean nicotine content is higher than 40. So our null hypothesis is always one of no difference. In this case, we're saying that we're going to assume temporarily that the cigarettes are no different than claimed by the manufacturer. In other words, we're going to assume, use correct notation, that the mean of the cigarettes we're testing really is 40. Right? So remember, the null hypothesis is always a statement of equality. So we're assuming that the true mean mu for the cigarettes is really 40. And then we're going to look for evidence to dispute that. Our alternative is one of 3 different things, but it's stated that we're testing to see if the mean is really greater than claimed. So the mean is greater than 40. That means we're using a right-tailed test, and because we're looking to the right of, we're trying to test to the right of 40. Bigger than 40. To check the assumptions on our test, we have to have randomly selected data, and they should be, we should either have at least 30 data points or they should be approximately normally distributed. We only have 10 data points, but we're given in the example that they are normally distributed. And so our assumptions are okay to use the test. And so now we have to actually go about using the test, which means we find the test statistic. Okay, so this is what we'll call T naught, because it's going to be based on a t distribution, and it's x bar minus the assumed mean over the standard error, or s divided by the square root of the sample size. So we have everything we need to fill this in. This is 43.3 minus 40 over 3.8 divided by root 10. And if we get our calculators out and finish that up, we get 2.746. That's our t-score, or t-statistic, for the sample mean of 43.3. So what we are after is to figure out the probability of getting something that big or bigger if the null hypothesis is really true. So this is kind of the picture of what we mean by a right-tailed test, or a right-sided test. So we have t is 2.746, and we want the probability of landing in the shaded region. Right? So if the null is true, what are the chances that we get a sample mean out of our 10 cigarettes of 43.3 or bigger? You can note, it's not necessary, but you can note that this is a t distribution with 9 degrees of freedom. Okay, so that's what the picture represents. All right, now to find the p-value, we need to use StatCrunch. And remember that since we want a right-hand area, we're really going to be looking at 1 minus the left area. Let's see, getting a little crowded here. Erase that bit of the picture. So we need the probability of getting a t-score less than or equal to 2.746 using a t distribution with 9 degrees of freedom. I'll do that in a StatCrunch supplement here in a bit. When we do that calculation, we get 1 minus, and that was, let's see, where did I do that? 0.989. So we get a 0.011 for the p-value. So the interpretation of the p-value, again, it's really important to be able to do this because it unlocks understanding of lots and lots and lots of different statistical tests, even if you're not particularly familiar with them. But what it means in this context is that if there was really, if the mean nicotine content of these cigarettes was really 40, then there would be about a 1% chance of getting a sample mean of 43.3 or bigger. So that's not very likely. This is strong evidence against the null hypothesis. Because if the null were true, we would have about a 1% chance of getting the results we did from our sample. Now, we sort of make this a little bit more precise. What we mean by strong evidence is determined by the alpha level that is set before we do the study. And so the alpha level is a 0.025. So if our results have a less than 2.5% chance of happening under the null hypothesis, then we say we have significant results, and we would, in a second, reject the null. So if we check a p-val against alpha, we see 0.011 is less than or equal to 0.025. So less than a 2.5% chance of our results if the null is true. And that means we shouldn't believe the null. Right? If the null was true, these are really unusual results. So that casts doubt on the assumption of the null. So we're going to reject it. In favor of the alternative. So we would be fairly convinced that in fact the mean nicotine level is greater than 40. So we reject the assumption that it's equal to 40 in favor of it being greater than. All right, so I'm going to go through a couple of different ways to do this example on StatCrunch, and that's coming in just a minute.